Bengt Fellenius dispensa comentários no mundo das fundações. Mais do que uma autoridade, uma lenda, que fez a gentileza de dedicar um pouco de seu tempo para participar do Fundcast e conversar sobre o passado, o presente e o futuro da engenharia de fundações. Fique com esse encontro especial que tivemos na Conferência Internacional do DFI.
Estamos no segundo dia do Congresso do DFI e FFC aqui em Bruges e temos a alegria de receber o professor Fellenius para fazer uma conversa conosco. Separamos algumas perguntas e eu entendo que ele é uma das maiores autoridades do mundo na parte de fundações, tenho uma grande admiração por ele e vamos fazer uma breve conversa. So, the first question is regarding capacity versus settlement. You often challenge the focus on load capacity. Why do you think this concept is flawed? What should engineers focus instead?
Capacity deals with a situation that should be far away from a reality. A structure cares about the actual load it provides to the foundation and the response for that load. The structure, if we give it some, say, human quality, it doesn't care about any increased value. It knows the load that comes there, and it's concerned with that will not create troublesome movement. Settlement. So it's settlement we look at. Capacity has nothing to do with settlement. So using capacity any form means disregarding what's important. It's a meaningless thing. And apart from that, it's dangerous because the industry doesn't know what it is. There are an infinite number of different definitions of capacity, and between a low certain number and high values, they differ by factors of 2 or 3, depending on the particular conditions. So if you have a value that can be 1.5 as large or twice as large that somebody else has, or only half of what you have, and then you're playing with a factor of safety or resistance factor of 0.6, or a factor of safety 1.5 or 2, whatever, it's meaningless, totally meaningless. So we should concentrate on settlement. Capacity has nothing to do with it. If you design for capacity, you have no guarantee that the structure will not fail. You may be wrong. You do not know what the settlement is. So it's an uncertain concept. If you design for settlement and know how to do it, that structure will never fail. Unless you're very wrong, of course, but that goes for everything else.
Right. I'll follow on a question regarding the Red Book. I would ask you, if someone reads your Red Book and remembers only one thing, what should it be?
What the takeaway from my Red Book? If somebody suffers to read it, it's almost 600 pages. I think the main takeout is look at the basic principles. Very simple. Read Terzaghi's engineering newspapers 100 years ago about the basics of soil mechanics, and make sure that these things are incorporated in your design approach. That's what I think my text should say. Look at the basic principles and then get the refinements later.
Perfect. Now, about loading testing, traditional static load tests are often considered as the reference test. Do you think they are enough to understand pile behavior? What's your view on base expanding devices like the toe box or expensive cells?
Yeah, two questions there that are pretty wide, both of them. A static loading test is a reference to the analysis, design, or whatever the context is. To understand the test needs understanding pile response quite a lot. It's the basic of pile foundation analysis to be able to interpret the static loading test as well as to simulate and predict, if you want, the response of a pile for this particular condition. Your second question is about the base expanding devices, as you mentioned. The importance of those, that's a tremendous advancement in the technology. They address the most important aspect of a pile foundation, the response of the pile toe. Once you know, or it's determined how the pile toe will respond to a load, you can figure out, even approximately, satisfactorily, what happens along the shaft. If you know the toe, and then, of course, what happens below the toe. Both these two devices, the toe box and the EB, they do not just determine what the response of a pile is, they build that response. The toe box gives you an answer and tells you how the response is, but it also creates that response. And so you have a device to construct the pile and give the answer at the same time. The same thing for the EB, less direct, but you can see how the expanded base expanded and what the pressures and stresses were, and can use that to know what is the expected response of this pile. And conventional pile installed, you don't know that. You will have to test it and interpret what happened. You're not creating it. Somewhat with a driven pile, you're driving against the resistance, and the last blow will tell you a bit what the toe resistance is. It's similar, but it's not a direct measurement.
Many designers subtract drag load from pile resistance as if it reduces capacity. You say that's a mistake. How should negative skin friction be treated correctly?
Too many engineers subtract the drag force, the force not a load, from the pile resistance. It does not reduce capacity, capacity defined as an ultimate resistance has nothing to do with the drag force. Subtracting it is a grave mistake, very costly. Does not improve the response of the pile foundation at all. It's worse than a mistake. It's dumb, ignorant, to be clear. And it's been shown this and explained for 40, 50 years. So not accepting this now is more than a mistake, worse than a mistake. Negative skin friction is just the direction of forces. We have negative skin friction, positive shaft resistance, direction of shear forces. You need to know them to do a proper design, but by themselves they're meaningless. We need to know what the response is in terms of shaft resistance, negative or positive direction. As to a drag force, it pre-compresses the pile. It's a good thing. I used to say that the drag force is the best friend of the pile. It gives you a pile that will compress less for a structural load and be therefore a better pile. Like pre-stressing of a concrete column. It's an internal force. We don't take away the pre-stressing force from a concrete column. So by now I think that knowledgeable foundation designers know this. Some codes have yet to catch up.
We now make a question regarding optical fiber. And what's your opinion on using optical fiber sensors to monitor load along the pile? Do they bring some advantage?
Well, the obvious advantage is that it gives the distribution more detailed. You needn't worry about where to put your gauges. The disadvantage is that it's a very sensitive system. It's also costly because the readout is very costly. It's sensitive to temperature, which doesn't really bother a pile that much, because when you're testing, the temperature is constant. It takes a little bit more knowledge how to do it than ordinary vibrating wire gauges. So I'm no objection. I'll be a bit more hesitant because if a wire breaks, I lose the entire instrumentation. One gauge that breaks, I have another one. People need to understand that piles are still bending, so you need two wires diametrically opposed to be able to compensate for bending. It's less common, but I think it leads the right way. We're not going to be installing single gauges at odd places, and the installation is much more laborious for intermittent gauges compared to one optic fiber that is attached along the reinforcement. So I've only been involved in 2 or 3 cases with optical wires, and unfortunately all 3 were a little bit in an experimental state and didn't quite work.
Good. I'll make another question here regarding what's the most common mistake you see in pile design reports today?
Oh boy, let me count the ways. And the main word here is the report. And report writing it's an art that has to be learned by engineers. And an engineer is often a person that never quite learned how to write in school and university. But as to mistake, writing poorly is not per se a mistake. You can read between the lines and see what it is. Mistakes is omitting observations, basic data. What was there before the test is as important as what happened during the test. And might say what's not so much a mistake as omission in reports is putting the measurements into some context of effective stresses, not just casual average soil description, but a little bit more quantitative, so we can correlate the measurements in the test to the geology, the geotechnical aspect. Some people are very competent in producing valuable reports and I'm referring then to the data that you can look into the details. The reports are not they report the test. They do not go straight to the design. A test report should not really give design recommendations. That's for a separate report, maybe by the same person, but often by a different company. The report's got to be complete in itself and have all the data that somebody needs for another context.
Well, now maybe another tricky question. In your experience, are most of piles today over-designed?
No, in over-designed, what it means, carrying more being able to carry much more load without excessive settlement. Well, in that sense, there should be, but the emphasis is over, meaning they're more capable than they should be because that costs money. Pile foundations were unnecessarily expensive. They cost money, but if they cost more money than needed, probably, because if we knew better what we did, we could make the foundations a bit cheaper. But pretty well every foundation project is over-designed, if meaning that they can take a little bit more without distress. And that's what they should do. We should have a margin. How many pulp foundations, if we limit it to this, can we accept to fail? If we design everyone as best as we can to just be right, by definition, almost half will fail. So we do them stronger. How many will still fail, and do we accept anyone's to fail? The reality is, if we have an answer to the question, we look at the number of pile foundations and look at the number of those who actually failed. It's about 1 in 1,000. And we accept that, obviously, or we would have changed the system. So I don't think they're over-designed, but they may be a little costlier than we really need to if we make sure to know a bit more of the individual cases.
So now talking about design codes and standards, many design codes still rely heavily on load capacity and fixed safety factors. Do you think current foundation design standards are outdated?
Yes, very much so. The current foundation design standards based on technology that developed over several decades, and that knowledge overall has not kept up with what we're able to do and know. So by necessity, they will always lag behind. With regard to capacity, it's ridiculous and dangerous. Fixed safety factors, stupid. The look at differential settlement of the foundation and build the code to respond to this. I tried a bit in committees I had by not giving numbers. You can't do that. But very important statement I got into the Ontario Building Code about 35 years ago, I think. Before a design is finalized, the geotechnical engineer and the structural engineer should discuss the design. Communication between different fields. In the later issues of it, they took that away. It was just an advice. They wanted a code that prescribed. And I think that advice is very important. Have the people confer with each other and compare and discuss the consequences of a design presentation or a recommendation. So we need there's a lot of more work on codes. And I don't like prescribed factors. I saw in the presentation here that you actually have 3 or 4 factors multiplying each other, very close to unity for addressing to different things. And how can you put numbers on essentially life in judgment? We need a factor for whatever the numbers you be for an inexperienced and designer, and a different factor if has some experience. That makes as much sense as some of the other factors I saw. But I would hate to give a number.
All right. So during your brilliant career, was there anything in pile design you believed for years and then changed your mind about?
Oh, the I've been I don't think and work the same way today on important things as I did 10 or 20 years ago. When I started out, I believed that effective stresses in clay were incorrect because that was silly and ignorant. Effective stresses determines the response. Our ability to actually determine what the effective stresses are in a moving system, that's a different thing, but they will control. I don't work with ultimate strengths for that reason. For the longest time, I thought pile groups were a sum of individual piles, of course, stressing the soil underneath a bit more, until I went 5 years ago or so, 10 maybe, realized that was wrong. When I first got interested in the so-called negative skin friction, I thought that it was a part of the design, and I supplied it with a separate factor as opposed to a resistance factor on positive strength. That was wrong. So I can pull out a couple of papers I've written over the years. They're available freely, and point out the paragraph where I'm utterly wrong. I won't. I was asked from people to indicate the papers I've written that would still be worth reading. My obvious answer were, you read them and tell me. No, of course you're wrong in the past, often. A couple of times I've been right without really understanding why. That's nice to know. But the process of anybody, you learn as you go along, and you discard some ideas or phrasings you used in the past to realize they're either wrong or not adequate. And that's the stimulants of professional life.
That's evolution.
Yeah.
Knowledge. So I'll make another question now about sustainability. And this year, the conference that we are here, the DFI EFFC conference, also focus on sustainability. How can geotechnical engineers reduce the environmental impact of foundations? What's the designer responsibility in that?
You're asking a question that's outside my expertise. I care about the environment, very much so. But how to apply that care to the issues I deal with in my daily practice, I don't really know. So I think it's looking after and making sure that decisions jive with the responsible environment or responsibility for environment. But precisely how to phrase that, I don't know.
And the last one practice to abandon. If there's one design practice still used today that you'd like engineers to stop doing, what is it?
Well, the obvious one, connected to the first question, quit talking about capacity and ultimate resistance, look at settlement. And it's not difficult. It takes a bit of training and knowing what settlement analysis is, but that's basic. Look at data. The other very strong advice of mine is look at data, get data, do measurement. The most important papers are the case history papers, well documented. They are the papers that last theoretical analysis and new methods. They may be interesting, but they will be superseded later. But good data will last and keep teaching us. Get data, have the society, the responsible authorities, repeat builders, always monitor how a foundation behaved over time and make that information available so we can use data as reference to our design. I think that is my strongest wish today.
Thank you very much. It was a pleasure to talk to you and record this quick interview, and that's it. Thank you.